Hey everyone, I'm Steve. I'm one of the SkyCiv API developers here in Sydney, Australia. In this video, we're going to be looking at the Excel plugin that we've created. So the idea of this is to help you incorporate into your existing spreadsheets or create from spreadsheets and export to structural 3D. To start with, you're going to need to install SkyCiv to the ribbon like I have up here. So you can do that by going to Insert and get add-ins if you haven't already. If you're on a Mac, it'll take you to the external site and you can follow through and add it. If not, I think on Windows, you can do it from within Excel. So once you've got that, you can open up the SkyCiv tab and you should have all these tools here available. So to start with, we're going to define a problem. So I was thinking we could create a facade grillage, just a simple one, say 2 levels with a curve on it. So that's something that we could do in Excel by using formulas. We might just think about what the facade's going to look like. Perhaps let's do a 2D bird's eye view of it. So if we go to draw, might draw with the trackpad here, that over here. All right, so if I just draw a circle and just think about what this is going to look like, our facade might be sort of everything above that second line there. So we would know our X coordinates as we just went along. Say if we went from -5 through to 5, not very good drawing there, but you get the picture. So if we know the X positions, we can work out the Y positions if we know a radius. So let's just pick a radius of say 25. So we'll just put R 25. Now this will be in metric, my model, using the metric system. And then we could perhaps just put in the equation for a circle. So x squared plus y squared is equal to r squared. So if we rearrange this, we could, because we want to find the y value, we could say y is equal to the square root, and we might even open the bracket there to make that obvious, of r squared minus x squared. So let's just give this a bit of a color, put input and that one yellow. Might just bump this text up as well. All right, so now let's think about our node positioning. So we could just put in here an ID, an X, a Y, and a Z. And we'll just start, the IDs can just go from 1 and onward. So what we do know is our X positions. So let's just start with -5, we'll go to -4, and we'll follow that through to 5. So once we've got that, that'll be our bottom row of nodes. Now I'm going to work with Y as my vertical axis in this case. So the Y value from this equation would actually be our Z's. So if we just give Y to start with a value of 0, we'll take that down to here. And now we can solve for Z, or what we've called Y over here, just by putting in equals square root. So we'll put in this and then the radius from over here. We'll just lock that with F4 to absolute value of B1. And then we can square that and take away x squared. Now we'll lock the column for this one and close that equation. Okay, so now we've got the equation in, we can drag that down and we've got some values. So let's take the x and the z. I'm holding command there to select the 2 columns, and we'll just do an insert a scatter plot with the curve on it. Might just change that to this one, and you can kind of see our curve here. So if we perhaps fix these axes up, we'll make the majors go up in 1s, and we'll do the same over here, 1s. So now if we make those boxes roughly square, then this is kind of a good indication of what our facade shape would look like from a plan view. So now we've created this, that would be our bottom level. We're going to need a few more levels. So let's say that the floor level was 2.7 high. We're just going to be using these same values and changing the Y to 2.7 and then 5.4 for the next floor. Let's repeat them. We'll take these values, paste them here, and then again down here, we're going to need to extend that. And let's just group these into the 11 nodes by giving it some color code. So we'll just make them a light gray. We'll make these ones the next shade, and this will just help us identify the different zones. The difference being that the floors need to increment, so we'll put in 2.7 there, and we'll take that down to here, and then we'll put in 5.4 here, and we'll take this down to here. Okay, so that creates us some nodes and coordinates. So we'll open up a SkyCiv sheet now by going over here, and we can click on setup, and this will create the S3D model template. So all of these definitions have been collapsed. You can go here to open them up. For now, we're just going to work with the nodes. Once we've set this sheet up, you can also go into SkyCiv settings, and I'll just move my picture here as this is going to start getting in the way. Myself over here. So in the settings, you'll be able to authenticate through there for more advanced functionality like solving or saving your models. You can set the vertical axis, a few other options, and any of your units as well. So this is all still very fresh. If you find any bugs, let us know so we can fix them up. But for now, we'll just go and start creating our model. So let's open up the renderer. At the moment, we're currently working on another renderer, which will give you more information, such as your sections and show you loads. But for now, it's a little bit more basic, just sort of shows you the shape, the layout. So nodes, members, with just a square section. It's still very helpful to see what you're creating as you put it into here. So let's start by putting the ID reference to the first one here. And then we'll take that. We might just make these a little bigger and might just grab all them and show more decimal places. Not too many. And then we'll just take that down to, it'll be about 36, okay, 35. So we'll get rid of that. And there you go. You can see the facade nodes coming up here. So another thing you might want to do is offset all of these back to the origin. So we could do that just by adding to this formula less the radius. So let's just go minus radius and hit F4 to lock that cell. So you can see that one's moved in. We can take that all the way down as well. The really cool thing about this is that it becomes a parametric situation. So we could change this radius and that'll become, you don't really have much to reference off here, but you can see it became a bit more flat. So if we took this down to say 5, it'll become very curved. But let's just take that back to 25 and head back over to the SkyCiv sheet. And now we'll look at putting in some members. So to start with, we'll just put in some node IDs there, carry them down, take them down a little way, and delete the ones we don't use later. And now it's important to know, if you're not familiar with these tables, is that this little handle at the bottom of the table defines what's in the table. And we use these tables to identify what should be extracted from the sheet. So it's important to make sure that all your data is inside this handle. So if we go up here, members are defined by a node A and a node B. We also need to give them a section ID. So that's, if you don't put this in, the renderer won't know what to do. So just grab them and you can take them, just give them a value of 1. You can change them later on when we get to sections. But for now, we'll just put in the nodes. So our nodes went from 1 being this one, and then 2, 3 along here, and then back to over here, 12 through, and then from here and to the end. So what we can do here is just copy the nodes in. So these, don't forget that these are referenced, so we're just going to need to copy the values again. So we'll take 1 to 11, go to here and paste the values. And then we will take from 12, 13, and take that down to here. Now 11 and 22. After that, we'll then step up into that next level. The next one will be this 12 here, and then following through to 22. From 22, we need to go to 23. So you can see them start to fill it up. Oh, that didn't work. We'll grab 21 and 22, drag that down. And now we're starting to get the vertical members. So now to go sideways, we know we got 1 to 2, then 2 to 3, and so on. So we could probably just grab all of these, paste the values, and then we'll grab from 2 to the end and bring that back up here. Now you can see we're starting to get a few random members here. We're not going to need any of these guys down here. And we're just going to need to fix up a few of them here. So the issue is when we go back from node 11 to node 12. So if we find that one, we know that's not meant to be there. So we'll just get rid of that. And then we know that 22 to 23 would also be wrong. There you go. So we can just grab these, shift them up, and then we can fix these last two as well. So we're going from 30 to 31 to 32, and then 32 to 33, section 1, and now that's our grillage. Now that we've got that, we're not too worried about any of these other parameters for now. So I might just close them, but keep the rest open. And now we'll start looking at sections. So we've added the section library in here. If you come into the SkyCiv ribbon, you can go to sections. And this just helps you, saves you sort of looking up what's meant to be in here. So what we can do is just say we want section 1. We're just going to have one section in here. And we'll just put a square hollow section, an Australian section. It's just a tube. And we can go to the library here. First things first, we're going to have to authenticate, because this is, to get this information, it needs to make a call to the API. So let's go to settings. Need to put in a username and key. So you can just click here and that'll open up this. Now there's also a reset API key here, which I'll use after this. So you can just paste your values in for authentication. Let that run for a moment. It'll just take 10 seconds or so. Authentication is typically the slower part of all the API processing. The rest of the solving is really quick. So now if we come back over here, we might just need to refresh this. So for me, I can just go to reload, or you can just close this window and reopen it. So now we're back to here, we can go to library. For me, I'm going to go to an Australian section. Steel 300, you can also search up here. We'll go to SHS, and then we can pick an SHS. So we'll go 89 by 5, and we're going to insert it into section 1. So if we had another section here as well, you see the table expanded to include it. We can now add it to either. So in this case, we're only going to have one section, so we'll just get rid of that again. And this is the member, the profile that we've selected, and we can hit insert. So that puts in the values. So that just saves you looking it up, and it just makes sure that the syntax that you put into here is correct. We need to add a material ID. So even though this says steel, that doesn't mean steel. This is just like a catalog item of the section properties. We can just minimize sections and create a material of ID 1, which is what we gave that section. Now this is another thing. I might look at adding some defaults, like a default materials pane, to save you looking up all this data. You can go to S3D and open up the materials pane, click one of them and just grab some values out of there if you like. We'll just give this some arbitrary values for now. Density of 7,850 kilograms. We'll give it an elastic modulus. Now this is in MPA, so we're going to have to give that 200,000. Poisson's ratio 0.27, yield strength, we'll say 270, and ultimate strength 410. Class, this helps us with the design modules. It just helps to recognize what members need to be checked. So if you're not sure about any of these headings, what goes in them, we've included the docs, API docs shortcut here. So if I click that, it'll open it up to the S3D model, which is what all of this information is we're entering here. So you can see all those headings that we have: members, section, materials. That's all of these. So they're all the components that make up an S3D model. So we're interested in finding out what the class key is for materials. So we can go to materials. That'll scroll down. This is a really long page. Scroll down and you can look in the table here and see that class is a string or text, which accepts any of these values. So we're dealing with steel. So I'm just going to put in steel. And then that's it for the materials. If we come to supports, we're going to need to add in a few supports. We'll look at adding one here, 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 and the same on the other side. So we'll have 6 supports, and we need to work out what those node IDs are. So we know our first one was 1, and then we went over to 11 on the other end. So that means the next one will be 12. And then the next one will be 22, and then the next one will be 23 and 33. Now, restraint code, for experienced engineers, this is no surprise. If you're newer to engineering, usually a 6 character code, which sort of defines the way the restraint moves. If we come into here and down the bottom there, I've added restraints, the restraint code. So even if you came to supports, there's a link here. The restraint code, and this just gives you a little explanation of what it is. So the first 3 letters are translation and the last ones are rotation. So we're saying here that this is fixed in all translations, X, Y, Z, and then X, Y, Z rotation, it is fixed, but in the Z, it is released to rotate about the Z axis. Now this is referring to the global axis. If we come over here, let's just have a look at that. We'll fix all the translations and we might just leave all the rotations free. So another way you can also write it is just with lowercase, if that just helps you to split it up. We'll take them, put them all the way down, and that'll do for supports. Now we'll add some distributed loads. If you open up, expand the distributed loads, you can see that it takes IDs. So that's the load ID, and then it'll also require the member IDs that we're applying the loads to. So we wanted to add them to these ones, so from node 1 to node 2, and then all the way to the end. So that's just going to apply a load only to our horizontal members, which is likely not the case in real life, but to stop this example from getting too big, we'll just keep it from 23 to 52. So that should have been in this column here. These should be 1 to 2, because that is the ID of the distributed load. So in our case, we want to add some negative Z. So blue is the Z axis here. Red is the X axis. So the negative Z, we're going to, let's just assume that we're applying a 1 kPa pressure for a wind load, say a very heavy wind load. We'll take the 1 kPa, the floor levels are 2.7, so that means the end members will have 1.35 applied to them. So we'll go 1.35, or this is negative 1.35, and we'll take that through to 11. That's also going to need to be the same on Z magnitude B. So if you wanted a tapered distributed load, you could change B, and it'll go from 1.35, say, down to 0 or something like that. Now 11 is the number of nodes, so our members will be 10, so we'll just get rid of this row, and then this will go to minus 2.7. We'll take that down to 20, put them here, and we'll also put that down here. You'll need to also put in zeros where you're not using it. I'll show you what happens if you don't. what I'll do is I'll leave out access and we'll run that, and you'll just see the error messages that you get. Position A, position B, so that's along the member. Where do you want to start? So you might want to start 20% from node A and only go to 80% of to second node of the member. So we'll just go from 0 to 100. So it's applied across the entire member, and then we'll take that all the way down. So load group, we'll just give that, say, WU, Wind Ultimate. And then access. So if you don't know what should go in here, you can click the docs and have a look at the S3D model. We want to go to distributor loads, and then you can see in the table what it accepts. So I've got access is a string or text which accepts global or local. So let's just put into here, oops, we'll put into here global. Now, if we left out a bunch of them, we'll see what happens when we run API functions on that. So if we wanted to open it in S3D, we can click up here, and this will authenticate, save the model, and then launch it in a window. So you can see that it's opened up a new tab here, error messages, with 29 errors. So it's saying distributed loads 2 should have required property axes. 3 should have a required properties axis. So it said that for each one. So that's what you'll get, messages like that if you left out values, but they're pretty descriptive. So you can come down, drop them down to the bottom, and then run that open in S3D function again. And this will save it to a file called temp-excel plugin in the top level of your directory. So it'll always overwrite that file. Now we've got it open in S3D, we can see that everything looks pretty good. We've got a bigger distributed load in the middle and a smaller one on the top and bottom. Our supports are in there. We could run solve, see if we get any issues. All right, so that's worked well. Now look at the displacement. You can see if I hold S and scroll, you can see the movement of the displacement. We could go to the renderer. We could turn up the deflection, put some member results on, say axial force might be interesting. And then we could also look at the displacement sum. That all looks about correct. So that's how we can quite easily create a model and open in S3D. You can also run these functions from within Excel and get the values in other sheets. If we wanted to do an analysis, we can just go to Analyze, select your analysis type, what results you want back. The results data is very heavy. There's a lot of it. So if you can, just try to set your filters on which ones you want. We'll just do envelope absolute max, run a solve on that. Just give it a moment. And you'll see that it'll open up some sheets down the bottom here. So it'll create sheets for your different load combinations or load groups. So down here we've got WU and we've got all the data for each member. So then you could take that and feed it back through your own calculations. We've got some information here, summary. This little results lookup just looks up the table, so you don't have to sift through it. You can just select load group, select a member ID, and sort of the type of results that you would like to get back. And so one's obviously a bad example. So now if we wanted to run design, we could do a similar process. Just come over to design and choose your design code. So I've got a metric model and I've got Australian sections, so I'm going to go with the AS code. If you ever get any issues saying that units are wrong, you need to make sure that the code that you're running is aligned with the type of sections that you've got. So if you're running a US code, your sections should be from the US section library. So it's pretty similar. You can select a member here to save you looking through the tables and see the results here. So that's about it for the Excel plugin. We're pretty keen to hear or get some feedback from the users. We want to keep adding more to it. We're pretty active in that regard. So if you've got any suggestions, jump on SkyCiv.com, log in, go down to the live chat in the bottom right and send us a message. Also, it's very new, so any bugs, just report them through to us and we'll fix it up. There's sort of a lot of different situations, so it's quite hard to cover all the different bugs that you might come across. Another thing we have too here to help you get started is samples. So you can look in here and you can pick something, a metric model that we've sort of preloaded for you. Anyway, that'll be it, and we'll see you in the next video.